Hello everybody, this is Mr. Ray. We're going to try our first distance learning lesson today. Uh, so according to our original schedule, this would be Unit 2, Lesson 5. I'll be putting these lessons under a new folder. Um, so some of the lessons we'll be taking out, some we'll be keeping, but if you want to refer back to your old lessons, this is the one. So today's lesson is on factored form of quadratic equations. So if we go back to where we were before our extended break, if you remember, the original quadratic equation looked like y equals ax squared plus bx plus c. Okay, and the a, the b, and the c were all variables. Were all numbers, could be integers, fractions, decimals, whatever. Now the a has to be something other than 0, but the b and the c can be anything, okay? Now what we called this form was the standard form. It always looked like that, okay? We also learned another form when we started changing the parabola by stretching, compressing, moving it around, reflecting it. We came up with this new form, which looked like this. Okay. There's a square there. There's a square there. That tells you it's quadratic. Now, in this case, you could see, well, here's another a. That's exactly the same value that the original equation would have. But we have these two new values, h and k. Now, if you remember, the h and the k turned out to be the coordinates of the vertex. So mathematicians decided to give this the name vertex form for good reason, because it gives you the vertex. So the vertex of this equation would be whatever the values of h and k were, would be the vertex. Okay. Now, before the break, we also talked about how there was a third form of a quadratic equation, and that looked like this. Still another a, and this time we had two binomials in brackets. Okay, again, the a, exactly the same as the other two forms. And if you remember, the a told you how much the parabola was stretched or compressed and whether it was reflected. And so that's going to be the same for all three forms. Now, in this case, the r and the s are the two new variables in this case, but they're actually going to be numbers when we work with them. But the r and the s turned out to be the x-intercepts, or what we call zeros. So now if you notice this is kind of, we've turned this into a factored form from the original. If you remember from Unit 1, we spent most of our time changing equations that look like this into equations that look like that. So we call this factored form. And in this case, I'll explain in a second, the r and the s are the x-intercepts, or we also call them zeros. So those are the three forms of a quadratic equation. Now, this doesn't mean they're different parabolas. They could all be the same parabola. They just are converted back and forth between these three forms. Okay, and we'll be doing that in a couple of lessons from now. So what we're going to spend some time doing today is looking at the factored form. Okay, so if you refer to our lesson note, I just bring that up here. So this is the lesson note. So we basically covered all three of these things here, the different forms and what the values mean. And the x-intercept, or the zero, is what the r and the s are. Okay, so what I would like to do is just maybe come up with an example of a factored form equation. So let's just start with the one we had up here with the a's and the r's and the s's. Okay, so that's what it looks like. So I want to explain why the r and the s are actually the zeros or the x-intercepts. Okay, so in order to do that, if I just did a graph of some parabola, opens up, so that would tell you the value of a is going to be positive. Um, now it's got these, it's going to have these x-intercepts. Um, now, if you notice, the thing about x-intercepts, and this is true with any equation, the x-intercepts always occur where y is equal to 0. So x-intercepts, that means that y is equal to 0. We learned that in grade 9, and you'll continue doing that into other grades as well. So since y is equal to 0 when we're finding the x-intercepts, I could just change the y in the original equation to 0. Okay, now here's the thing, and we're going to actually be doing this concept quite a bit in about 4 or 5 lessons from now. So it's good to kind of maybe learn it now. What we're actually going to look at is solving this equation. Now, if something, I basically have, I'll put the a in brackets just for the sake of making it look like it's a number, it's something multiplying with these two things. So basically we got these three things multiplying with each other, and the result is 0. So anytime you multiply 2 or 3 or 4 things and get 0, that means one of these must be 0. Okay, so if we looked at each one separately, well, this a value, we've already said that can't be 0. That's going to be some number, so we can kind of ignore that for this case. So basically what this tells us is either this factor or this factor must be 0. So I could look at that and say, well, that must mean that x minus r is equal to 0, and this must mean that x minus s is equal to 0. Now, they don't have to be both true at the same time, just one of them has to be true. So if you were to solve for x here, you could say, well, the only way that x minus r could be 0 is if x was r. And the only way that x minus s could be 0 was if x was s. So here are the two solutions. So if we kind of go back to where we started from, we're trying to find the x-intercepts by making y equals 0. So we basically went through this exercise, set y equal to 0, and set each of the factors equal to 0 to find these are the two x-intercepts. And that's basically what I told you from the start. If you have an equation that looks like this, that must mean that r and s are the x-intercepts. Okay, so we'll be going into this in more depth in a few lessons from now, but for the time being, if you see an equation that looks like this, let's put some real numbers here because we got way too many variables for it to make a lot of sense at this point. If I had something like this, so if I turn my if I turn my quadratic equation into factored form, okay, if I want to find the x-intercepts, that must mean, well, I could do it, I'll do it the long way, but you can do the shortcut later on. You're basically setting y equal to 0. You have this on the right is still the same. So in order for this, well, this could never be 0, it's 3. In order for this to be 0, x would be equal to 2. And in order for this factor to be 0, x would have to be negative 3. Okay, so this tells you that the two x-intercepts are x equals 2 and x equals negative 3. So if we're looking at an example back here, this is obviously a little bit off, but it would tell you those x-intercepts that the parabola actually has on the graph. Okay, and I'm sure most of you, once you start the questions on this section, eventually you'll kind of look at this and go, oh, I just kind of look at this, and whatever the opposite sign of this number is, or the opposite sign of that, that's going to be my x-intercepts. So in this case, it would be x equals 2, x equals negative 3. So that's the shortcut I was talking about. But it doesn't always work. I'll show you an example of something that doesn't work that easy later on. Okay, so if we go back to our original lesson, okay, so we've kind of covered off the key concepts except for this third one, which we'll talk about in a second. Okay, so in this case, move this up a bit. Okay, so here's our equation here, and you can see it's already in factored form. So it's y equals 2x plus 1, x minus 7. Okay, and again, this is the slightly longer way. You don't have to do it this way every time. You set y equal to 0 because you're finding the x-intercepts. And when you do that, you can say, well, the only way this could be 0 is if, well, that can't be 0, but this could be 0 if x was negative 1, and this could be 0 if x was 7. Okay, so that gives us the x-intercepts. Okay, now the whole question is saying describe the graph of this quadratic relation. So we've just found the x-intercept, so that allows us to go onto the graph and to say that we've found 2 points here. So x equals negative 1, that's one x-intercept, and x equals 7 is the other. Okay, now this next part is going to be new because it asks us to label the x-intercepts. Well, we've just done that. The vertex and the axis of symmetry. Well, how do you do that if you just know the x-intercepts? I mean, if we had the equation in vertex form, we could do that very quickly. But in this case, we just have the x-intercept. So there's actually a pretty interesting way to find the vertex and the axis of symmetry. So if you remember the whole thing about a parabola, it's very symmetrical. So that axis of symmetry is always going to be exactly halfway between the x-intercepts. So we could do that by trying to figure out on the graph, but the best way to do it, so in this case we're going to do axis of symmetry. To get the axis of symmetry, you just take your two x-intercepts, you add them together, and then you divide by 2. And really what you're doing here is just finding the average of these two values. So if we look at that, that's going to be 6 over 2. So the axis of symmetry is x equals 3. So if we go back to the graph, we find x equals 3 along here, and we can say, well, this is our axis of symmetry. Well, the axis of symmetry, you know, it's sort of interesting, but it doesn't really give us a point, but it does give us, it does tell us that somewhere along here is where the vertex will be, okay? And we can kind of do a bit more investigation in here. Since the a value is 2, that tells you that the parabola opens up, okay? So it's going to come down here and back up. So that tells us that the vertex should be down here somewhere. It should be below the x-axis. Okay. Now to get the exact location, well, we already know the x-coordinate of the vertex. It's 3. But to get the y-coordinate, so I'll just work on the vertex here. So the vertex, we know it's x equals 3. That's what we got from above. And to get the y value, we just use the original equation of the quadratic. So we know that y is equal to 2, and then x plus 1, well, we can just replace the x with 3 because we know the value of x is 3. So that's 3 plus 1, and then times 3 minus 7. And if we simplify this, we get y is equal to 2 times 4 times negative 4, which is equal to negative 32. Okay, sorry, y equals negative 32. So the vertex is the point 3, negative 32. Okay, now unfortunately my scale here isn't all that great, so let's adjust it a bit because negative 32 would be well off the page. So let's do a little change here. Let's do this to 30 and minus 40. This would be positive 10, 20, 30, 40. Okay, so we know the vertex is along here, and we know it's going to be negative 32, which is right about here. Okay, and now we've got 3 points on our graph. We've got the vertex and the two x-intercepts. We could actually get the y-intercept, but we weren't asked to, so we'll do that a bit later on in another lesson. But we can do a fairly good sketch of this with just those 3 points. We know the vertex is where the parabola changes direction, so I'll do my little cup there and then try to do a good job of making a nice smooth curve for the parabola, and that's what that would look like. Okay, one thing I want to mention is whenever you're doing this process and you substitute in the x value of the vertex into here, you're always going to get the same two numbers here, one positive and one negative. Okay, it always works out that way, so don't be surprised if it seems like it happens all the time. Okay, if you go to the next page. Okay, so this is the same idea. Find the vertex and x-intercepts of this quadratic relation, sketch. So basically the same question. So we should be able to do this a little quicker now. So if I set, let's find the x-intercepts first. So I'll set y equal to 0, and the rest of the equation would be the same. And I'll put x-intercepts here, because that's what you're going to get when you set y equals 0. And from this, you can see, well, one of these three things must be 0 for this to be 0. So, well, that can't be 0 because it's 4. It never changes. But these two could turn into 0 in this case if x was negative 3 or if x was positive 5. Okay, so those are your two x-intercepts. So I can go to the graph. I can go to the graph and plug in my two x-intercepts. X equals negative 3, x equals 5. Okay. All right, and then to get the vertex, we do the same thing as we did before. So we'll find the axis of symmetry first. Okay, and we do that by axis of symmetry is always x equals a value. We know it's going to be between these two values, halfway between. And the way we get that is we average the two values of the x-intercepts by adding them together and then dividing by 2. So in this case, that's going to be a 2 over 2, which is 1. So the axis symmetry is x equals 1. And then the vertex, we know x equals 1. That comes right from the axis symmetry. And the y value, we go back to the original equation, plug in x equals 1. So y is equal to 4, 1 plus 3, and 1 minus 5. And that's equal to 4 times negative 4. So again, we unfortunately get a really big number here. This is going to be y equals negative 64. Okay, so that tells us the vertex is the point 1, negative 64. And so let's go back. We can pencil in our axis of symmetry. It's somewhere along x equals 1. And we now know it's negative 64, which is well off our graph. So let's do go by 15s here so it can fit on. Okay, so we know it's negative 64, which is somewhere down here. And again, it looks similar to the last graph, but it is different because of the scale. So again, I'll do my nice smooth parabola. Don't forget to put arrows at both ends because it does go on forever. Okay, last question here. This is a word problem. The Dufferin Gate is a parabolic arch with the left base located on the x-axis 4 units to the left of the y-axis. Label the x-intercepts and vertex. Okay, so this is an actual real gate that's at the CNE. It's at the entrance gates. It's called the Dufferin Gates because it's on Dufferin Street. So something like this, the gate is like a parabolic arch. It opens kind of upside down. But in this case, we've got the ground, which you could say that's the x-axis, but it will never go below, at least you can't see it. So what I will do here is I'm going to have a y-axis and an x-axis here. Okay, so this will be just a rough sketch to get us some information. So the scale will be a little bit off, but don't worry about that for this example. Okay, so I'm not going to draw a negative y-axis because the arch doesn't go below the ground, which would be down here. So this is above ground and this is below ground. This is to the left and right. Okay, so let's go back and get some information. So it's a parabolic arch, so it's going to be that shape. It's 20 meters tall, so the highest point of this will be at 20 meters. So on my y-axis, I'll put 20. And we can assume these are in meters, and these are in meters as well. So that's going to be my highest point. So I can kind of draw a line along there, and I know the arch will max at that point. Now let's look at the rest of the information, and it's 22 meters wide. Well, that we just know it's from where it connects to the ground, it's 22 meters apart. There's some more information in this part here which will get us a little more detail. So it says the left base is located on the x-axis 4 units to the left. So if this is the y-axis, that's x equals 0. And if it's 4 meters to the left of the y-axis, that would be at -4. Okay, so now we have a solid reference point. So if we take our other information that we haven't used yet, the fact that it's 22 meters wide, well, if the left point where it meets the ground is there, well, I just add 22 to go to the right point, and that would be, well, -4 plus 22 would be 18. So that's where the right point will touch the ground. And what we can do here is we could do a calculation for the axis of symmetry. That's going to be x equals the average of these two values divided by 2, which is going to be 14 over 2, so that's 7. So we know the vertex will be right about here at x equals 7. So if we go up, where these two lines meet will be the vertex, and that's at the point 7 for the x and 20 for the y. Okay, so we now have basically what we can consider our x-intercepts and the vertex. So if we do our sketch of the parabola, it looks something like that. In this case, I'm not going to draw arrows going down because it just ends there. Okay, so there's the x-intercepts. I could label them here, and this would be the vertex. Okay, so part B says determine an equation to model the arch. Okay, so there's a couple ways we could do this. We're going to try a new way. So basically we know the x-intercepts, we know the vertex. So we could just plug this into, if you remember back to here, since we know the vertex, we know h and k, we could plug those values in and then solve for a and get our equation. But what we're going to do is try this new technique. We know what R and S are because those are the x-intercepts. Plug those in and figure out what A is. So that's exactly what we're going to do. So our equation, without knowing anything, sorry, that should be an R, x minus S. So we know from here that we could say, well, R is equal to -4 and S is equal to 18. So when I put that in here, I get x equals, now you have to be careful here, it's x minus R, R is -4, so it's x minus -4, so it's x plus 4. And S is 18, so it's x minus S, so it's x minus 18. Okay. Now, if you were just given this equation, remember the little trick you had, just take the opposite sign, gives you the x-intercepts. So -4 and positive 18. Okay, so, you know, we got 2 of the 3 parameters here, R and S. We're just missing A. And in order to get that, we're going to use the fact that the vertex is the point 720. That's the only other point we know. So in this case, don't forget, now we could plug in any point into here and get the correct equation, but the only point we do know is the vertex. So it doesn't have to be the vertex, but in this case it does, because that's the only point we know. But if somebody told us another point along here, we could put that in instead of the vertex. So in this case, vertex is x equals 7, y equals 20. So I'm going to plug in where y is. That's going to be a 20. X is going to be 7. Okay, so I'm going to get 20 equals A times 11. Sorry, that's an 18 there. And -11. And there's that little thing that happens all the time. These two numbers are the same, but the opposite signs. Now, if I need some more room here, so that tells us that, okay, so 20 is equal to A times -121. Now, we're not used to seeing, this is like the coefficient, it's multiplying A. So I could just rewrite this in the correct order. And then what we're going to do to get A is just divide both sides by -121. Now I put the negative up there just because it's better form. So there's our value of A. So now we've got A, so we're going to take, remember this version here, we're going to take that, we're going to plug in our Y value that we just got. And there is our equation. Okay. Now it's always worthwhile just to make sure you got the right sign here. The fact that A is negative means it should be opening down, and of course that's the case because it is an arch. Okay, so that's how that works. I just wanted to add one more little piece of information here before we're done, and that was, I alluded to this earlier. So if I had an equation that looked like this, so say 2x minus 3x plus 4. So that looks like factored form. Or does it? Sorry about that. Now the problem here is, remember factored form was a x minus r, x minus s, and then r and s were your x-intercepts. Well, this one's okay because I could just say, well, s is -4, but this one's a little bit odd, and it's because that coefficient is there. So I can't, this is where the little shortcut fails, because a lot of students in grade 10 will say, oh, the x-intercepts are -4 and +3. Well, -4 is correct, but +3 is wrong. So I want to show you why. So what we can do here is, if you see anything other than a 1 in front of the x's here, you can just say, well, if you remember, if we set this equal to 0, I'll do that up here. To find our x-intercepts, well, 3 can't be 0, but these two factors could be. So this is sort of the longer way of doing it, but it shows where the mistake can be made sometimes. So basically 2x minus 3, if that's equal to 0, then this would be equal to 0. So you set each factor equal to 0, and then you solve for x. So this one's pretty straightforward. We already knew this one. Negative 4 would make that 0. That's pretty straightforward. This one here, you have to do a little bit of work. Okay, so remember equation solving. We add 3 to both sides, and then we divide both sides by 2, and we get x equals 3/2. So that's actually the second x-intercept. It's not positive 3, it's positive 3/2. So one way you can kind of, if you don't want to do it this way every time, here's the shortcut. You basically take the opposite sign of that, so that would be positive 3, divide by the coefficient of x, and get that. So hopefully that this lesson shows you a bit more about factored form. We've got some assigned questions here in the lesson. I'd like to get you to try most of those just to get a good feeling for what you're doing. I'll be posting the solutions the day after the lesson is up, but do try it yourself so you'll be able to figure this out. Okay, thanks very much, and we'll see you on the next lesson.